Hello everyone. My name is Sumudu Tenakone. I am a data scientist presenting this educational video content series aimed at improving data science literacy in the community and helping those who are moving toward becoming data science professionals. Couple of years ago, I started writing an article series putting together my fascination, thoughts, and views on data science as I experienced the field of data science in the past 3 years since I began my data science career in 2017. Those articles were aimed at addressing data literacy in the community. The first 2 articles were published in Medium and few of them were in the process of seeing the light for a longer time, and I hope they will eventually get published. Data science is a field on a rapid development phase. We are now at year 2022. Looking back the past 2 years, I see lots of development in the data science field, technology and perspectives of the community, and my views and thoughts were also broadened than the time I wrote it. This is a narration of the second article of that series, Data Science for Everyone, titled Getting to Know Your Data, Part 2, Seeing Data Through the Data Iris, published in April 2021. The previous articles in this series, Getting to Know Your Data, Part 1, laid the foundation for understanding some fundamental concepts on data. Let's continue discussing different perspectives we can look at data to enhance our understanding of it. In the timeline of human history, we almost took data for granted. However, with the advent of computer and information technology in the late 20th century, the value of data became more pronounced. With the advancement of big data analytics, data mining, artificial intelligence, and machine learning, our appreciation of data significantly increased and continued to be rising. This led to a new era of digital transformation which disrupted many fields and our everyday lifestyles. A detailed discussion on data in connection to human history planned for a future article. You can see on the screen the data usage in the civilization timeline. To succeed in this digital era, every individual in society should develop at least a fundamental understanding of data and learn how to handle it to make its best use. As we discussed in the previous article, digital data is now an integral part of our life, and we cannot separate ourselves from it. Therefore, we should take some extra effort to understand data better and use it as a strategic asset to positively impact our personal lives and work. This getting to know your data is a crucial step in any data-driven project. States of data. When the data sitting on physical storage such as a database, file server, data warehouse, or backup drives can call as data at rest, and when it is moving through a network of systems that has a temporary presence in one location can be called data in motion or data in transit. When the data being actively utilized by applications, example, select, filter, modify, update, we can call the data in use. Unless the data under an especially restrictive setting, example, backup, highly protected, and regulated sources, data always changes its state between these 3. Important V's of data, describing characteristics of data to understand the complexity and the challenges. The term big data came to discussions in the 1990s, which was always associated with an obvious question of what qualifies for big data. The answer you can find is commonly associated with the volume and rate of data accumulation. In simple terms, big data can be defined as the volume or rate of accumulation of data that is large enough that the commonly used software tools cannot handle it. However, with the rapid advancement of computer software and hardware technologies in the past 3 decades, that defined limit to big data was a fast-moving target. To better understand the data, several organizations and authors explored and conceptualized a metric consisting of the terms start with V describing the qualities of data. Even some authors define that for big data, I would consider this applied to all data regardless of its size, rate of accumulation, or use. You can find some variations to this metric between each publication addressing different perspectives we can look at data. This article intends to consolidate the classic V's of data metric and extend it further by adding the new perspectives addressing data security, vulnerability, and privacy, visibility. The classic 3 V's of big data. Volume, variety, and velocity is considered as classic 3 V's of data. Let's look at them one by one. 1. Volume. Volume in the physical nature is defined as the amount of space occupied by a 3-dimensional object. In sound applications, we use the term to quantify the degree of loudness or sound intensity. Volume is also used to name a part of a series of creative content, example book, magazine, music album, etc. In computing, a single accessible storage area with a single file system is known as a volume. When it comes to data, the volume is used to describe the amount or size of data in focus. In the previous article, we discussed units of measuring data as a quantifiable entity. With great volume of data comes great responsibility. The speed and bandwidth of the data communication improved significantly over the past couple of decades. Simultaneously, data collecting and receiving devices were added to the systems operating over the internet and local networks. More and more businesses, financial, healthcare, science, and technology institutes rely on digital data. Their practitioners, customers, clients, and users are also moving away from traditional methods and going along with the digital transformation in their practices. In this rapidly evolving situation, we should not surprise to see a large expansion of data accumulation worldwide. According to Statista, the volume of data/information created, captured, copied, and consumed worldwide is projected to follow an exponential increase, and in the year 2020 it is estimated to be 59 zettabytes, ZB, which is 5.9 times 10 to the power 13 gigabytes, GB. When the data volume grows high in an organization comes with elevated challenges such as how and where to store them. Storage. How can they protect from adversaries and physical or software-related damages? Security. Creating disaster recovery plans and backups, backup and disaster recovery. How can the data efficiently and reliably make available to organizational use? Data serving. The need of data storage to handle the volume demand. The data volume is a deciding factor in choosing which data storage medium needs to be employed. The time before the internet, the most common ways of moving data from one system to another were the portable magnetic storage mediums such as tapes, floppy drives, up to a couple of MBs, and zip drives, up to hundreds of MBs, which created many difficulties in handling as well as expensive when the capacity gets larger. When optical drives such as CD, 700 megabytes, DVD, 4.7-17 gigabytes, came into the data storage arena, they become more economical. Many of the handling issues associated with magnetic disks were gone. The latest member of optical drives is Blu-ray disks that can hold up to 128 gigabytes of data. In parallel to optical disks, the magnetic hard drives and solid-state drives went through a rapid evolution in the past couple of decades. We now can store terabytes of data in a single storage medium available in the consumer market. However, in most industrial applications, data storage consists of multiple storage devices connected. Those data clusters support the high volume of data being accumulated and also facilitate performance computing. With the rise of cloud data storage platforms in the past few years, more organizations started to utilize that to have an advantage of getting free from the burden of managing their own physical infrastructure while utilizing globally distributed and securely maintained data storage. 2. Velocity. We identified above the three states of data. From those three, the data at rest and data in motion create many challenges for data management. If our application requires data in real time, even a slight delay in data transmission can greatly impact its value. Data velocity refers not particularly to the data transmission rate but generally the rate of data generation or accumulation in a system. When the system response to the data velocity is not properly managed, we may lose the time-sensitive value of the data. We may miss the opportunity to capture portions of data. This highly affects the systems that need near-instant results based on data such as weather systems, payment processing systems, healthcare, and many other mission-critical systems. The challenges of higher data accumulation rates directly couple with those with the data volume because the large volume of data being accumulated ultimately needs to store for future use. In some special cases, data storage is not required but providing real-time analytics results utilizing the incoming data streams which require performance-enhanced computing hardware and software tools. 3. Variety. Data comes in various forms, structures, and formats. In the previous article of the series, we discussed this in detail. You may find data in structured, tabular, semi-structured, such as XML, JSON, or unstructured form. Sometimes you will get data in different file types, as binary or plain text. It could also be a data stream or archive/zip file. The ability to handle all varieties of data is required in modern data-driven organizational work. Understanding the 3 V's of data through real-world examples. Let's examine a couple of practical examples. You can read through and try to fill in the shoes of data professionals and scientists working on these scenarios and understand the complexity and challenges they must overcome. Let's take an example from scientific domain. A large-scale science experiment studying fundamental particles. They use state-of-art particle accelerators to collide subatomic particles, example, protons, neutrons. Let's take an experiment to quantify and characterize fundamental particles resulting from the collision detected by high-resolution detectors. Those detectors generate a large volume of data per one capture. Since these measurements to be made within a very short time interval, and the experiment required a large number of captures per one collision, fast data acquisition has to happen. The largest particle physics laboratory in the world, CERN, reports they generate 115 petabytes of data per year collectively from their experiments. In this example, it is obvious the volume of data generated will be enormous. The associated challenges will be storing the data and making them readily available for further processing and analysis utilizing high-performance computing facilities. The extremely high velocity of data generated from detectors needs to be carefully handled at the experiment time. Any mishap, such as distortion or loss, in capturing the data can ruin the entire experiment. Since the facility operation and experiment costs are very high to repeat, this data becomes precious. Therefore, the scientists and instrumentation teams prepare very thoroughly and take careful measures on the instrument and data pipelines to run the experiments smoothly. The data generated here will mostly be numeric matrices arranged into a tabular form or binary files with some semi-structured metadata. Therefore, variety can be less challenging. Let's look at another example from business domain. Now let's look at an example closer to our day-to-day life. Consider a large retailer with tens of thousands of stores worldwide, hundreds of millions of customers, millions of employees, and selling millions of items. The data generated from the number of transactions happening at a given time, velocity, and the variation of data sources and types, variety, used in the business process will be high. In reality, several petabytes, 10 to the power 6 gigabytes, GB, of data can be accumulated within a day of such a large organization. For any business, the real value of data is measured by how it is being used to make an impact on the business itself. Apart from the data-driven applications used by the staff and customers, there can be thousands of data scientists, analysts, mining useful data, performing various analyses, generating reports, building predictive machine learning solutions, etc. In this example, you may feel the challenges are much complicated than the scientific application above. You may be right. Apart from the immense volume of data and the velocity, the globally connected systems and networks, the users, and the internal and external data generating sources will add several layers of complications. We will address some of them in the next section when we look beyond the 3 V's discussed above. The data iris, beyond 3 V's of data. Since the 3 V's have established their ground as a metric in the data science/big data community, several organizations and authors extended that by adding more perspectives. As a result, 4 V's of data, adding veracity, 5 V's of data, adding value, 8 V's of data, adding visualization, variability, and volatility, emerged in the literature. Several authors also extended it further into 10 V's of big data. After reviewing the previous publications, consolidation of some terms, and adding the new perspective to security and compliance, we can construct a metric of 10 V's to describe the qualities of data which we can assemble into the concept of data iris. The word iris is meaningfully chosen here, which was borrowed from human anatomy, where the iris in our eye is responsible for controlling the amount of light reaching the retina. When we look at our data through this data iris and intuitively maneuvering the components, we should see our data better than ever. Let's keep exploring the other V's making the data iris. Let's look at them one by one. Veracity. We may sufficiently handle the challenges of the volume and velocity of the data. Still, we need to make sure the data can be trusted, accurate, free of ambiguity, and quality is maintained through data collection and storage. A data-driven organization needs to invest heavily and apply adequate strategies in maintaining the veracity of data to get the best use out of it. Consuming untrustworthy, inaccurate, or poorly sourced data may reduce veracity, which can lead to depreciating the value of the products and may pose elevated challenges keeping up with compliance and regulations. Variability. The characteristics of data can vary throughout its usage or transmission. The rate of data accumulation or transmission can vary based on the circumstances. The form of data can be changed, the nature of data sources can be changed, data itself can transform into different formats within the organization. Data practitioners in an organization need to keep up with these changes and address them accordingly to avoid potential impact on the applications, products, or business operations. Value. Data has become an important asset to both individuals and organizations, governments, industry, educational and research institutes, manufacturers, etc. Some people recognize today, we are in a new gold rush era where the data replaced the gold in the game. Like unprocessed gold taken out from a mine, data has less value in its raw form but has a great potential to add value based on how it is managed, processed, analyzed, presented, and preserved by the miners, in this case, data professionals. We know when the gold is purified and used to make a jewel, the value of the end product multiplies significantly than the gold in raw form. The same happens when data is properly used to derive solutions to scientific, health, social, and business problems such as generating insights, descriptive analytics, predictive analytics, machine learning, etc. The data analytics solutions embedded in an application or product amplifies its value, quality, and usefulness. Data is considered as gold in the digital era. We can also say data in the digital era is equivalent to oil in the industrial era. The value of data goes up with accuracy, completeness, and accessibility. It goes down if the data is not offered timely, out of context, or the data is commonly available. As an example, think of a list of person names you got in an Excel file. Is it valuable data? Maybe not without proper context, example, list of people attending an event. How about adding another column, data point, with phone numbers? Now the value of the data you have will increase significantly given that the name to phone number assignments is accurate. The real phone numbers we can reach those individuals, and complete, we can find phone numbers for a significant portion of the records. The value of this data is getting elevated when more data points, example email address, age, hometown, profession, etc., are added. Volatility. Like almost everything in the universe, data has its own lifetime. It could be the time till the storage runs out of energy or till the time it wipes out from the storage. However, data also has a lifetime based on its validity. Depending on the application, this lifetime can be defined by the policies, laws, or regulations. Sometimes, the value of data is significantly depreciated where the data becomes no longer relevant or useful. Some data science professionals can argue that data will never become irrelevant in general, and it can be valuable for future applications requiring historical data. Data volatility will lead to making some organizational decisions such as how much we should invest in preserving this data, storage, backup, etc., or when we should get rid of them. Viscosity. When the data feed into a system at a higher rate, velocity, and the data sources and formats are different from each other, variety, internal friction can be developed from the resistance created during the data integration processes. This resistance can be amplified when different tools and technologies are used within the same organization to store and transmit data, such as local DB server versus cloud hosting. The mix and match of different data sources, formats, tools, and technologies can be seen in data projects on any scale. Viscosity can also get amplified by human factors such as decision-making and availability of expertise. When the data is used for real-time analysis or applications such as creating summaries, visualizations, dashboards using streaming data, the viscosity plays a greater role. Therefore, it needs to be mitigated using proper methods and tools for data loading/retrieval and processing. Visibility. One critical challenge with the digital transformation is protecting sensitive data from adversaries who intended to misuse data for their malicious intents or harm the entities attached to the data assets. To make everyone participate in a digital data platform be comfortable, we need to establish some standards, policies, and regulations on accessibility and visibility of data assets. As a result, restrictions can be imposed on who can access particular data assets, from which locations or networks they can be accessed. Visibility is directly related to privacy and data protection. For example, when we get to work with a data asset, we need to know our limits, restrictions, and boundaries to use the data available to us responsibly without exploiting it for a short-sighted gain. What parts of data can we use in our work? What parts of it can we share with the work products? What are the methods, example, aggregating, anonymizing, masking, excluding, etc., and tools we can use to do the data projects in compliance with the data privacy policies, laws, and regulations are important questions to be answered concerning the data visibility. As examples, we can take General Data Protection Regulation, GDPR, apply for European region, California Consumer Privacy Act, CCPA. More countries, regions, and states on the way of making or improving new regulations. Vulnerability. We previously discussed how the data is strongly tied to our lives and livelihood and realized that bond increases with time. Similarly, we looked at an analogy saying, data is the new gold. When data or data-oriented systems are handled in an irresponsible manner or left without proper protection, it can bring serious harm to individuals, communities, and nations. The recent data breaches and various other attacks on organizational data infrastructures remind us of the importance of having our data-driven applications, storage platforms, and communication networks protected from physical and virtual attacks by adversaries. Therefore, in all data-related work, we should be more cautious and proactive about the vulnerabilities they possess. Properly assessing vulnerabilities and addressing them in the early stages of a data project is a crucial task regardless of the scale or domain of that project. However, in real-world data projects, key challenges are addressing the vulnerability. Organizations face higher demand for the fast delivery of their products to meet market needs while allocating less attention and resources, money and time, on addressing vulnerability is a common scenario. Another constraint is the lack of expertise within the organization. When the decision makers and executives are illiterate or short-sighted on vulnerability issues, they could take their organizations on a destructive path. Summary. Instead of comprehending the definitions of the V words or how many are there, let's consider this a metric to capture the essential qualities and the complexity of data we work with. We can use that to better prepare for the challenges associated with them. I hope the content presented in this article narration shed some lights to your understanding about the data and the importance of learning more about it. In this video content series and future articles, I will discuss the topic in detail, incorporating the new learning I get every day. As mentioned at the beginning, data science evolving rapidly, and we should keep ourselves in a constant learning phase to keep up with it. Thank you for listening and see you all in another video.